Hi guys, today we are going to see the important problem related to the mesh analysis. Okay, especially the super mesh analysis. In super mesh analysis, we are going to solve the problem. So it is a May 2018 question and it's a part C question. Okay, so it's a 15-mark question, part C question. So you see the question, use the technique of mesh analysis to evaluate the three unknown mesh currents. Okay, so this is the question. Use the technique of mesh analysis to evaluate the three unknown mesh currents. So this is the given circuit. So in this circuit, you see one battery is there. Okay, this is a voltage source of 7 volt, and here you see it is a current source. Okay, so if you are putting one circle within that, we are putting one arrow, means this is said to be the current source. This current source value is 7 amps. Okay, and some resistances are connected in some manner. Okay, and we have to solve this circuit using mesh analysis. So the first one, in mesh analysis, you know the procedure how to solve in mesh analysis. So first we have to identify how many meshes are there. Okay, in the diagram. So you see how many meshes are there? 3 meshes are there. This is the first mesh. Okay, this is the second one, and this one is the third one. So there are 3 meshes in the given circuit. And the next one, we have to mark the current. So here in question itself, the current direction is given. Okay, so the current flowing in the first mesh, it is given as a I1. Current flowing in the second mesh, it is I2. And the current flowing in the third mesh, it is said to be the I3. Okay, so the currents are marked in the question itself. But now using mesh analysis means we have to apply the KVL equation for each loop. Okay, so already you know. So for each mesh, we will have one KVL equation. So by solving the 3 KVL equations, so we will get the variable I1, I2 and I3. Okay, so it is the procedure in ordinary mesh analysis. But in this circuit, so one current source, okay, you see this current source of value, the 7 amps, is connected between the mesh 1 and mesh 2. Okay, if one current source is connected in between 2 meshes means, so that circuit we have to solve it in super mesh analysis. Okay, so what is super mesh analysis means? If any one current source is connected in between the 2 loop means, we can't write a KVL equation for this first loop and third loop. Okay, so we can't write the KVL equation for this first loop and third loop. So if we can't write means, how can you write that KVL equation means? So we have to write the super mesh equation. So what is super mesh equation means? While writing the super mesh, that is KVL equation for that super mesh, we have to consider this current source value as 0. Okay, but if this current source value is 0 means this branch is completely eliminated, and we have to combine this first loop and third loop. Okay, so that is for this combined first loop and third loop, we have to write one KVL equation that is said to be the super mesh equation. Okay, so that is the one thing. And another one thing, this you see the loop 2. Okay, in loop 2 there are no current sources, simply resistances. So we have to apply one KVL equation for the second loop as it is. Okay, so already one super mesh equation is that there is a KVL equation for second loop is there. But we are having the variable 3 variable. But in order to solve 3 variable, we need at least 3 equation. So what about the third equation means? You see this current source, in terms of this current source, we have to write one equation. So you see the current source is connected in this branch. Okay, so this branch is common for loop 1 and loop 2. Okay, but we have to write this 7 amps current source is nothing but this current I1 is flowing from top to bottom, this I3 is flowing from bottom to top. So for the subtraction of what is the current flowing in this branch, through this branch, I1 minus I3. So I1 minus I3 equal to 7. It is another one equation. So by using these 3 equations, we have to solve this circuit. Okay, that is the procedure. Okay, so we will see one by one. So for the first one, so we have to identify the independent loop. Which one is the independent loop? This loop 2. Okay, so this since in this loop 2 only there are no current sources are there. Okay, so that's why we have to apply the ordinary KVL equation to this loop 2. Okay, so we have to apply the KVL equation to this loop 2. So what is the KVL equation for this loop 2? So you see, so the current starting here, so 2 into I2 plus 3 into what is the current flowing through this 3 ohm resistor. I2 is flowing like this, I3 is flowing in the reverse direction. So the subtraction of current I2 minus I3 into 3. Okay, you see, so 2 into I2 plus 3 into I2 minus I3. Then if you are coming here, 1 into what is the current flowing through this resistor? It is a I2 minus I1 equal to 0. Okay, so this is the KVL equation. So in this KVL equation, you just rearrange. Okay, you split the terms. 2I2 plus 3I2 minus 3I3 plus I2 minus I1. So you collect the terms. So we will get minus I1 plus 6I2 minus 3 into I3 equal to 0. So you just consider this is a equation number 1. Okay. So we derived the one equation in terms of I1, I2, I3. Okay. So the second equation, it is obtained by this current source. Okay. You see this current source. This current source is connected common for loop 1 and loop 2. About this current source value, this 7 amps, it is nothing but a subtraction of the current I1 and I3. Okay, since you see in the current source direction, which current is there? I1 is there. About the subtraction of this current I1 and I3 is equal to 7 amps. So that is a second equation. I1 minus I3 equal to 7 amps. It is a second equation. And the third equation, we have to write a supermesh equation. So what is supermesh equation? This while writing the supermesh equation, we have to make this current source as a 0. But you know, if the current source is 0 means this current source, it is said to be the open circuited. Okay. At the time, what about the diagram? So the supermesh diagram you see like this. Okay, since in this point one current source with one resistance is there, so you know we are making the current source is 0. So the current source 0 means here open circuited. So what about this resistance? This resistance is also, the series resistance is also, that is open circuited in nature. That is no current is flowing in the resistor itself. Okay, so that's why we will get one supermesh equation. So what is supermesh? The combined that is the combination of this mesh 1 and mesh 3. It is said to be the supermesh equation. But now we have to write the KVL equation for this supermesh. Okay. But here while writing the supermesh equation, we have to consider the current flowing in this part is I1. Current flowing in this part is as it is I3 you have to take. Okay. So but now you apply KVL equation. About what is the KVL equation for this supermesh? But you just start here. So we are starting here from the battery means minus to plus. Minus to plus is said to be the voltage rise. So the voltage rise 7 equal to, while coming here, the 1 ohm resistor is there. What is the current flowing through this 1 ohm resistor? The I1 is flowing like this. I2 is flowing in reverse direction. But the subtraction of I1 and I2 is flowing through the 1 ohm resistor. So what is the voltage drop across the 1 ohm resistor? So 1 into I1 minus I2. Okay, then while coming here, there is a 3 ohm resistor is there. So what is the current flowing through this 3 ohm resistor? There are two current, I2 and I3. So I2 is flowing like this. I3 is flowing like this. So two currents are opposite direction. So 3 into I2 minus, that is 3 into the current I2, that is 3. Okay, while writing the equation for this supermesh, so 3 into the current I3 minus I2. Okay, then when we are coming here, the resistor 1 into what is the current flowing through this resistor? It is 1 into I3. Okay, you see 7 equal to 1 into I1 minus I2 plus 3 into I3 minus I2 plus 1 into I3. Okay, so you just split the terms. So if you are splitting the term, we will get 7 equal to I1 minus 4I2 plus 4I3. This is the equation number 3. Okay. But now we are having the 3 equations. This is the ordinary KVL equation for loop 1. This is one equation. And in terms of the current source, we got one equation. And the third equation is this equation, supermesh equation. So in order to solve the variable I1, I2, I3, so we may use substitution method or matrix method. So the matrix method is easy to solve. So that's why I am using the matrix method only. Okay. So you just convert the equation number 1 and equation number 2. Okay, you see equation number 1, equation number 2, and equation number 3 into this matrix format. Okay, so how can you write this matrix? You see, so in the first equation, you see what is the coefficient of the variable I1? -1. What is the coefficient of I2? 6. What is the coefficient of I3? -3. Okay, but we can write the first row as -1, 6. You see, -1, 6, -3. Okay, similarly in second equation, you see, in second equation, the coefficient of I1 is 1. There is no coefficient of I2, so it is 0. What is the coefficient of I3? It is -1. So 1, 0, -1. Okay, similarly in third equation, the coefficient of I1 is 1. Coefficient of I2 is -4. Coefficient of I3 is 4. Okay, into the current I1, I2, I3 equal to the constant. So in the first equation, what is the constant? 0. In second equation, what is the constant in that right side? 7. In third equation, what is the constant? 7. So 0, 7, 7. Okay. So from this one, so we have to find out the three miscurrent I1, I2, I3. So in order to calculate the I1, I2, I3, first we have to find the determinant of this constant matrix. Okay. So for the determinant del equal to, so you know, -1 into 0 minus of this one. So we have to solve carefully. Then minus of 6 into this thing. Then -3 into this one. Okay. So we determined the del value as a -14. Okay. Similarly, we have to find del I1. What is del I1? In the 3 by 3 constant matrix, you have to replace this first column. Okay. This first column -1, 1 by this constant 0, 7, 7. Okay. So you just replace this first column by this constant. Okay. Constant. And you have to find out the determinant value. So that determinant value you calculate as -126. Okay. Similarly, we have to find out del I2. What is del I2? In the 3 by 3 matrix, you replace this second column by 0, 7, 7. This constant values. Okay. So this constant value. So by here you just find out the answer for this del I2. So the del I2 calculated as -35. Similarly, we have to find del I3. What is del I3? In the 3 by 3 matrix, you just replace this third column by this constant value 0, 7, 7. So we got the answer del I2 equal to -28. Okay. So after calculating del I1, del I2, del I3, we have to find the mesh current I1, I2, I3. Okay. So what is the current I1? The current I1 is nothing but del I1 divided by del. Okay. So we calculated the answer -126 divided by -14. So the answer is 9 amps. Okay. Similarly, I2 equal to del I2 divided by del. So -35 divided by -14. So 2.5 amps. Similarly, the I3 value is del I3 divided by del. So the answer is 2 amps. Okay. So these are all the mesh currents flowing through the given circuit. So this is the answer. So it is a very simple problem. It's a part C question asked in 2018 question paper. Okay. So this is the method. So what is the difference between the ordinary mesh analysis and the super mesh analysis? In a circuit, if one current source is appearing between two loops. Okay. If one current source, not voltage source, current source. If one current source is appearing between common between the loop 1 and loop 2 means, so that circuit we have to solve it in super mesh analysis. So in super mesh analysis, we can't write the KVL equation for this first loop and third loop separately. Okay. So we have to consider the first loop and third loop combinedly. So that combined loop under the consideration of this current source is 0. Okay. So we have to write the KVL equation for the super mesh. Okay. It is a one equation. The another one equation is this separate KVL equation. Then third equation is this current source value. So this current source value can be written as it is a subtraction of I1 minus I3. Okay. So we have to solve the three equations. So after solving the three equations, either the substitution method or the matrix method, so we will get the answers. So this is the answers for I1, I2 and I3. Okay. So thanks for watching. For more videos, please subscribe my channel.